Hi everybody. So in this video, we're going to look at graphical methods for solving fractional inequalities. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So we've been given the equation that y equals 6x over x minus 1. We've been asked to sketch the curve and then to use that sketch to solve this inequality. So if I just sketch a pair of axes, there's a few key coordinates that we need to consider. The first one is when x equals 0. Well, if we substitute 0 into here, then we get 6 times 0. Our numerator will be 0, so y will equal 0. Another coordinate is if we say x tends to infinity, then y will tend to 6 lots of infinity over infinity minus 1. Now, when we're dealing with infinity, the negative 1 becomes negligible, so we don't need to consider this. And then you can see that the two infinities will cancel. So as x tends to infinity, y will tend to 6. And I'll sketch this on our graph. And then we need to consider that x tends to negative infinity. We'll substitute this in. So we get 6 lots of negative infinity. Negative infinity, again, take away 1. But this negative 1 is negligible compared to the size of negative infinity. So we know these two will cancel. And again, we get the line y equals 6. Another point we need to consider is when the denominator equals 0, because we know at this point we'll get a undefined value, and this will give us a vertical asymptote. And you can see this will be when x equals 1. So I've shown this vertical asymptote on our graph. So we know the curve must pass through the origin, and there'll be a horizontal asymptote at y equals 6 for negative values of x. So it'll come like this, and then from this point, there'll be a vertical asymptote when x equals 1. So we'll get something that looks like this. We know there's no value for x equals 1, but as soon as x gets beyond that, well, this negative will shoot off to positive, because this denominator will then become positive. So then we'll have a positive infinity, and this will then come down to our horizontal asymptote at y equals 6. So it will look something like this. So for part B, we can use this sketch to solve this inequality, because we know now that y must be equal to 3. And then we want the curve must be less than the 3, so the curve must be below the 3. And that's this part of the curve here. So at this point, the curve 6x over x minus 1 will be equal to 3. We can solve this equation, so 6x must be equal to 3x minus 3. So x must be equal to negative 1. I'll label that on our graph, x equals negative 1. So our solutions then lie from x equals negative 1 to x equals positive 1. So x must be less than 1, but greater than negative 1. Okay? Well, thank you for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.